Alright, so let's say you're given this diagram, a guy trying to pull this mass at an angle of 30 degrees. And suppose the question wants you to keep the crate moving with constant velocity. How hard must you pull if the coefficient of kinetic friction UK is 0.3? Would you know how to solve? If not, continue watching this video. So we can start off by drawing a free body diagram for the situation. So we have our mass here, the normal, and the weight force. Noting that the weight force is going to be 500 newtons in this question. I forgot to put that. The guy is pulling the rope, so there's going to be a force of tension in the rope in the same direction as the applied force. We can draw that here at an angle of 30 degrees. We can also define a coordinate system, the x and y, and it's going to be positive in this direction. Apply our Newton's second law equation for the x direction. Look at our free body diagram. Our two forces in the x directions are going to be Tx and the force of friction. You can plug both those in and we get this. Then we can find the tension in the x direction by using this triangle here. We have to use trig, use cos theta is equal to adjacent of hypotenuse. With respect to 30 degrees, the adjacent is going to be tension in the x, and then the hypotenuse is going to be t, so we can plug both those in and then multiply by t to get the tension in the x direction alone, which we get this here. And then the force of friction is going to be just equal to mu k n, so we can plug both those in. Acceleration in the x is going to be equal to 0 because the velocity is constant, which means the mass will not be accelerating. So we can plug that in, and then we can bring mu k n to the other side, and we get this expression here. This is all we can do with this. It's important to note that we have two unknowns, the normal and the tension force. Find the expression for the normal force, we can use the summation in the y equation here. If we look at our free body diagram, we have three forces, the normal, the tension, the y, and the weight force. So we can plug those in and we get this expression here. And then we're gonna have to use the same trig to find the tension in the y. And if we do that, we get Ty equals T sine theta. And then the weight force is equal to 500 newtons and the acceleration in the y is equal to 0 because we can assume that the object is not moving in the y direction. And then we can bring both of these terms to the other side and we get this expression here for the normal force, which we can use to solve if we plug it into our other equation we had for the normal. And doing so, we get this here. Bring the tension term to the other side because that's what we're solving for. And then we can use this trick here to get tension alone. So we can multiply it by t over t. That's the same as multiplying by 1. And so we get tension by itself here. We can multiply both sides by 1 over cos theta minus mu k sine theta just to isolate for tension. Plug in our knowns for mu k and theta. And then we can solve to get this value here for the tension. This is the force of tension felt in the rope for the mass to be traveling at a constant velocity, which means it must be the force the person needs to pull with. If we look at our diagram here, the force felt in the rope is going to be equal to the force applied.